The pressure in a bicycle tire is 105 psi, so that's a pressure, at 25 degrees Celsius. So I'm never going to deal with Celsius. So as soon as I see Celsius, I add 273 to that number. So that's 298. Okay, so 105 psi at 298 kelvins in Fresno. You take the bicycle up to Huntington, where the temperature is -5 degrees Celsius. Okay, so -5 plus 273. We get 268. What is the pressure of the tire? And it says that volume and number of particles is constant. So I'm just going to cross those out. So my initial pressure is 105 psi. My initial temperature is 298 kelvins. My final temperature is 268 kelvins. So my temperature went down. Since temperature and pressure have a direct relationship, whatever number goes here should also go down. Okay, so again, this is the equation that I have. I'm going to copy this down, but I am not going to include the variables that I have crossed out. So I have pressure and I have temperature, and those are the only variables I'm going to write. So P1 over T1 is equal to P2 over T2. Now, when I see this, I want to immediately get rid of my fraction. So I'm going to cross multiply. Okay, so T1 P2 is equal to P1 times T2. And now I can plug things in. So my initial temperature is 298. My final pressure, I do not know. My initial pressure is 105. And my final temperature is 268. Okay, so I've kind of run out of room here, so I'm just going to draw a line and start again up here. So on the left side, I still have 298 P2. And on my right side, I can multiply these numbers together. So 105 times 268, I end up with 28,140. I divide each side by 298. Crosses out on that side. I'm left with P2. So 28,140 divided by 298. And we end up with 94.43 because I'm going to round this 2 because there's a 9 next to it. And my unit is PSI.